In this video, I'm gonna show you how you can use the KNN, the K nearest neighbor classification method in R. For this example, we're gonna use the empty cars dataset, which is already pre-installed in R, and most of you might already know it. So let's at first take a look at this dataset. It's the motor trend car road tests. And actually there are 32 observations on 11 variables. For our example, we're going to use the number of cylinders, so it is this one over here. This one is actually our qualitative variable. And we're also going to use the weight, so it's WT, and miles per gallon, so it's mpg. So we're simply going to attach this empty cars dataset to our R session, so that our further calculations are easier. And the next thing we're gonna do is we're gonna get some kind of visual impression of our dataset. Therefore, I'm using the library lattice and I'm plotting an XY plot of this dataset. So as you can see on this scatter plot, we have three groups. We have cylinder counts 8, 6, and 4. And there is definitely some kind of relation between miles per gallon and the weight and the class or the cylinder count. So we are now going to create some kind of a model to classify the number of cylinders, and we are using weight and miles per gallon as our quantitative variables for this model. The next thing we're going to do is we're going to activate the library class. If you do not yet have installed class, you would now need to install it first and then activate it by using, for example, the library function. So I'm gonna run this line. And the function we are using from this class library is called KNN, for K nearest neighbors. We're gonna take a look at the help section for this KNN function. And down here you can see the arguments which you are actually incorporating in this KNN function. In order to perform a KNN analysis in R, we now need to specify the train data, which can be a matrix or a data frame with our training dataset. Then we also need to have a test dataset, which again can be a matrix or a data frame. And this one is actually the data we use to test if the model actually works. And then we need to specify the number k. This one is actually the number of neighbors we use for our model. And we also have the argument cl, which is the factor of the classification. In our example, it will be the number of cylinders. We could also incorporate some kind of extra arguments, like for example L, which is a minimum amount of votes for a class. Then we could also specify use.all, which is the specification of the tie handling. So for example, if we would have a k of 4 and we have 2 votes for class 1 and 2 votes for class 2, this argument would actually tell the computer how to handle those ties. And we also have an argument to tell the computer if it should show the proportion of winning class votes or not. So for our example, we are now going to create a train dataset. I'm calling it train. And this is actually the miles per gallon column and the weight column from our empty cars dataset. And I'm using the cbind function. So this is now the train data frame. And I'm also specifying a test dataset. I'm calling it test. And this is actually a vector of 26 for miles per gallon and 22 for weight. If we actually take a look at the plot, you would see that this test data point would be somewhere over here, which is in the middle of the blue section or the cylinder count of 4. So if our KNN model works fine, it should actually give us an output of class 4 for this test data. So the function looks like this. I'm calling KNN for K nearest neighbors. I have the train data frame from over here. I have the test data, which is this vector over here. I have the classification, which is the number of cylinders. I have K, So the computer should actually count the two nearest neighbors, and they also want the proportion of the winning counts. So now I'm running this line, and as you can see, I'm getting class 4 as my output. And this is actually also what this plot would indicate. So it should be somewhere over here in the blue area, which is the class 4. And I'm also getting the proportion, which is 1. So that means that 100% of the winning counts, or 100% of those two neighbors, are in the blue area. So this is actually one way in how you can do k-nearest neighbor classification in R by using the KNN function and the class library.